Good day, everyone. This is Engineer Nelson James Yagonia, and I am taking up Masters of Engineering major in Water Resources Engineering. And for this subject, CE275 Surface Water Hydrology, I will be discussing about Unit 6, which is flat routing. Basically, the contents of this report will be the routing process, basic equation, hydrologic routing, and hydraulic routing. So, flood routing. What is flood routing? It is a technique of determining the flood hydrograph at a section of a river by utilizing the data of flood flow at one or more upstream sections. The two broad categories of routing are reservoir routing and channel routing. The difference between these two is that in the reservoir routing, the water surface slope is zero, while in channel routing, it is a non-zero value. So in this section, we will be concentrating only on one channel routing. Various factors such as channel storage, resistance, lateral addition or withdrawal of flows, and etc. When a flood wave passes through a reservoir, its peak is attenuated and the time base is enlarged due to the effect of storage. Flood waves passing down a river have their peaks attenuated due to friction if there is no lateral inflow. The addition of lateral inflows can cause a reduction to attenuation or even amplification of a flood wave. Flood routing is the technique of determining the flood hydrograph at a section of a river utilizing the data of flood flow at one or more upstream sections. The hydrologic analysis of problems such as flood forecasting, flood protection, reservoir design, and spillway design invariably include flood routing. So the objectives are at the end of this unit, the students must be able to develop and derive routing equations for flood routing analysis and to differentiate between hydrologic and hydraulic routing methods and their applications. What is routing process? So for more um, more definition of flow routing or flood routing is a process. It is a process whereby an outflow hydrograph is determined at a point in a stream, reservoir, or lake resulting from a known inflow hydrograph at an upstream point. The inflow and outflow hydrographs may represent daily or monthly stream flows or flood flows resulting from a short duration storm. So the purpose of this flood routing is to derive the hydrographs from rainfall distributions, estimating the water yield at a specific point, developing design elevations of flood walls and levees, studying the effect of a reservoir on the modification of a flood peak, determining the size of a spillway, and six other flow-related objectives. So routing process. In hydraulic routing, the flow is described through a set of hydrodynamic differential equations of unsteady state flow, and simultaneous solutions of those equations lead to determination of the outflow hydrograph. Hydraulic routing is in and based on the principles of hydraulics, in which flow is computed as a function of time at several locations along hydraulic system. It involves complexities of varying degrees, while hydrologic routing procedures, on the other hand, do not solve the hydrodynamic equations, but approximate solutions of those equations without their direct use. Hydrologic routing is a simple but lump flow process that provides the direct result at the outlet. So the basic equations of flood routing are the equation of continuity used in hydrologic routing as the primary equation states that the difference between the inflow and outflow rate is equal to the rate of change of storage. So this is the equation of continuity. I, which is the inflow rate, is equal to Q, which is I is the inflow rate minus Q, which is the outflow rate, is equal to the change of storage with respect to time. So I minus Q is equal to ds dt. Alternatively, in a small time interval t, the difference between the total inflow volume and total outflow volume in a reach is equal to change in storage in that reach, where I bar is equal to average of I bar times delta t minus q bar times delta t is equal to delta s, wherein I bar is equal to average inflow in time t and q bar is equal to average outflow in time t, and s is equal to change in storage. So by taking I, which is equal to I1 plus I2 over 2, and Q is equal to Q1 plus Q2 over 2, and S is equal to S2 minus S1 with suffixes 1 and 2 to denote the beginning and end of time interval T, and can be written as I sub 1 plus I sub 2 over 2 multiplied to delta T minus the quantity of Q sub 1 plus Q sub 2 over 2 multiplied to delta T is equal to S sub 2 minus S sub 1. So the time interval T should be sufficiently short so that the inflow and outflow hydrographs can be assumed to be straight lines in that time interval. So hydrologic routing. In hydrologic routing, the three elements of the routing process are connected by the basic continuity equation, where I and O are the rates of inflow and outflow respectively. The routing process is accordingly classified into two broad types, the reservoir routing and channel routing, or stream flow routing. The former approach is applied to reservoir routing, and the latter is adopted in stream flow routing. So then in terms of numerical approximation, the above equation can be written as, so the above equation means, so I sub 1, I sub 2 over 2, S sub 1, S sub 2 over T, and O sub 1, O sub 2 over 2, multiplied to the quantity of L cubed T raised to 1, where subscript 1 is at the beginning and subscript 2 at the end of the routing interval delta T. So in hydrologic routing, there are also two types, which is the reservoir routing and the channel routing or stream flow. So reservoir routing. So this diagram, we can see the inflow, dam inflow outflow schematic diagram. So this one with the use of, there is a dam or a structure. So with the structure, you can see that there is then second is the channel routing or the river reach. Channel routing models how flood waves propagate along a channel. So it accounts for attenuation and time lag of the flood peak. So there is one method used in channel routing, which is the masking method, wherein O sub t is equal to k times the quantity of x I sub t plus 1 minus x times I sub t minus 1 plus the quantity of y minus k multiplied to O sub t minus 1, where k is equal to storage constant and x equals to weighting factor, which is greater than, where x is greater than 0 but less than 0.5. This is for rivers. So this is the comparison between the river and reservoir routing. So in terms of storage, river routing is the function of inflow and outflow, while on the other hand, reservoir routing is the function of water surface elevation. Then another feature is the method wherein in river routing, we will be using the masking num, and in the reservoir routing, methods used is modified poles. And the last feature is in the application. So for river routing, it is used in natural channels, while reservoir routing are used in reservoirs, detention basins, and others. The next is hydraulic routing. Depending on the number of terms included in the solution of the hydrodynamic equations, the hydraulic routing procedures are kinematic routing, diffusion routing, and the dynamic wave routing. The simplest of the three methods is the kinematic approach, which has been successfully applied to overland flow and stream flow routing problems. So wave phenomena can be described by the hydrodynamic equations. The continuity equation of waves has two unknowns, the velocity of propagation and area of flow, and a second equation which is therefore required to describe the phenomenon fully. So since it has two unknowns, therefore we need to have also two equations. So their energy loss are insignificant, or when such losses can be assessed accurately, the energy equation is very convenient for the second equation. So in hydraulic routing, one method used is the dynamic methods. So these are the conditions considered in the dynamic method. So when when flow conditions are rapidly changing, backwater effects are present, dam break or flood wave movement. So dynamic methods are needed for urban drainage modeling, river flooding with bridges or constrictions, dam failure simulations. So these are the common uses of dynamic methods. Then comparison between hydrologic routing and hydraulic routing are, in terms of model complexity, hydrologic routing is simpler, pure assumptions, uses storage and continuity equations, while on the other hand, hydraulic routing are more complex and uses continuity and momentum equations. For data requirements, hydrologic routing has less data required channel geometry in flow hydrograph, while hydraulic routing, on the other hand, needs more data, which are detailed channel geometry and flow data. Also, for the accuracy, hydrologic routing is less accurate, but improvements have narrowed the gap, while hydraulic routing is more accurate, especially for unsteady flow dynamics. So since hydrologic routing is simpler and fewer assumptions, therefore we can also expect that it is less accurate. And complex complex methods, or for since hydraulic routing is more complex, so we can also expect that the results derived are more accurate. Also, in its application, hydrologic routing is widely used in flood forecasting and channel routing, while on the other hand, hydraulic routing is used in complex systems such as also backwater effects and steady flows. And lastly, for the computational requirements, hydrologic routing is simpler to compute and can be done with spreadsheets or basic software, while hydraulic routing requires specialized software such as HECRAS and numerical methods. So when you are using numerical methods, means that uh, the computational methodology is more complex, of the higher level of complexity, and hence, since it is complex, we can also expect that the data or the results that will be derived are more accurate since it is complex, while hydrologic routing, since it is simpler and also simpler to compute, in fact, it can be done through the use of spreadsheets and basic available softwares. So we can also expect or conclude that hydrologic routing is also uh, less accurate. So I therefore conclude that flow routing is a basic process of hydrology employed to find the conversion of an inflow hydrograph into an outflow hydrograph while passing through a channel, reservoir, or any other hydraulic system. It is of essential importance in many everyday applications such as flood prediction, water resource management, and hydraulic structure design. The two major techniques of flow routing are hydraulic and hydrologic, which are characterized by varying levels of complexity, precision, and data demands. Hydraulic routing is based on precise hydrodynamic equations and gives a physically based solution, whereas hydrologic routing reduces the process by using continuity principles to approximate the behavior of flow in a long sense. Each technique has a set of advantages with applicability to certain situations in water systems. Overall, effective planning, management, and mitigation in hydrologic and hydraulic engineering require understanding and using flow routing methods. So that is the end of my presentation, and thank you very much for your time. Once again, this is Engineer Nelson Jones Yagonia. Thank you very much.